Hello, friends. Welcome to everyone joining us today from around the world. When we think of the planets in our solar system, Mercury often seems like the simplest one. It is small, rocky, closest to the sun, and notoriously hot. But beneath that seemingly straightforward exterior lies a world of profound mystery. Despite numerous missions and decades of study, Mercury continues to baffle scientists, presenting paradoxes after paradox, and that challenges our understanding of the planetary formation and the evolution. Today, we are going to take a deep dive into the Mercury, the solar system's biggest riddle, exploring why this tiny world holds some of the most perplexing secrets in our cosmic backyard. Let us start with the basics. Mercury is the innermost planet, orbiting closer to the sun than any other world. This proximity means it's always experienced the extreme temperature swinging from scorching 430 degrees Celsius to minus 180 degrees Celsius at night. It is also remarkably small, only slightly larger than Earth's moon, making it the smallest planet in our solar system. For a long time, Mercury was often overlooked in planetary science, overshadowed by more dynamic giants or intriguing prospects of life on Mars. Its extreme condition and challenging observational proximity to Sun made it a difficult target for study, but with missions like NASA's Messenger spacecraft, which orbited Mercury from 2011 to 2015, and the joint European Japanese Pepe Colombo mission, which is currently en route, we have gathered unprecedented data, and with every new piece of information, Mercury reveals itself to be less simple and more puzzling. It's a planet that constantly defies expectations, presenting series of paradoxes that have kept scientists scratching their heads. Perhaps the biggest puzzle about Mercury is its incredible dense and disproportionately large core. Scientists estimate that Mercury's iron core makes up to about 60% of its total mass, roughly 85% of its radius. To put that in perspective, Earth's iron core makes up to only about a third of its mass. This makes Mercury unique among the rocky planets. Why is it has a core so massive? There are several leading theories, each with its own set of challenges. One idea, known as the giant impact hypothesis, suggests that early in its history, Mercury might have suffered a colossal collision with another large celestial body. This impact could have stripped away most of its lighter, rocky mantle, leaving behind mostly the dense core. Evidence for such an impact exists elsewhere in the solar system, for instance, moon formation. However, simulating an impact that could leave Mercury with exactly its current composition is very tricky. Another theory, which is there, that the sun intense heat during the early solar system might have vaporized much of Mercury's original rocky mantle, leaving the heavier iron behind. A third idea suggests that the Mercury simply formed differently, perhaps from a unique distribution of material in early solar nebula that was unusually rich in iron. Each theory has its own merits, but none fully explains Mercury's massive iron heart without raising further questions. It's a composition that simply doesn't fit the standard model of how rocky planets should form. Here's another head scratcher. Mercury is shrinking, not in the way a balloon deflates, but on a geological timescale. Data from the Messenger mission showed extensive network of cliffs and scrapes across Mercury's surface. These features, some hundreds of kilometers long and several kilometers high, are thought to be formed when the planet interior cools and contract, causing its crust to wrinkle and fold like a drying apple. Scientists estimate that Mercury has shrunk its radius by about 7 kilometers over the last 3.8 billion years. This ongoing contraction is surprising for such a small planet. Smaller bodies like Moon tend to cool and solidify more quickly, meaning their significant geological activity, including global contraction, usually ceases early in their history. Mercury, however, still shows evidence of recent tectonic activities, suggesting its interior is still relatively warm and active. Why is it shrinking now? Why it is so significant? It ties back to the iron core. As the molten outer core slowly cools and solidify, the planet effectively loses volume, causing the surface to buckle. But the extent and the duration of this shrinking are still a puzzle, suggesting that the thermal evolution of Mercury's interior is more complex and prolonged than we previously thought for such a small world. Adding to the intrigue, Mercury possesses a surprisingly strong global magnetic field. This is remarkably because, based on its small size and relatively slow rotation, one day on Mercury is about 58 Earth days. Scientists initially didn't expect it to have an active dynamo. The process within planet's liquid core that generates magnetic field, that is what we call electric dynamo at a planetary scale. Our Earth's strong magnet is generated by the rapid convection of molten iron in its outer core. For Mercury, a smaller planet that should have cooled faster, maintaining such a dynamo is significant enigma. Scientists believe that some form of convection must still be occurring within Mercury's massive iron core, perhaps driven by chemical processes or the gradual solidification of the inner core. But the exact mechanism remains a subject of intense research. This magnetic field is crucial because it helps protect Mercury's surface from the harsh solar wind, even if it is much weaker than Earth's. And speaking of extremes, how about this? Despite surface temperature that can melt lead, Mercury has water ice at its poles in permanently shadowed crater in the polar region, where sun's rays never reach and temperature remains frigid, so cold for ice to survive. This ice is thought to have been delivered by comets and asteroids over billions of years, similar to how water is believed to have arrived on Earth itself. The riddle isn't the presence of ice itself, but how it could persist on a world so incredibly close to sun, trapped in this cold, dark traps, which is the north and south pole of the planet. It's a testament to the extreme conditions and surprising hidden corners even on the most seemingly straightforward planets. Mercury's peculiar orbit also holds a special place in the history of science. For centuries, astronomers observed a slight, unexplainable wobble or precession in Mercury's orbit around Sun that couldn't be fully accounted for by the Newtonian physics. This tiny discrepancy bothered scientists for decades. It wasn't until the Albert Einstein published his general theory of relativity in the year 1915 that the puzzle was elegantly solved. Einstein theory, which describes gravity as a curvature of space-time, precisely predicted the observed precession of Mercury's orbit. This was one of the first major confirmation of the general relativity and triumph of the modern physics. Even with Einstein's explanation for its orbit, Mercury continues to challenge our model of planetary interiors, geological evolution, and even the atmospheric dynamics. The ongoing PEPI Colombo mission, a joint effort by the European Space Agency, which is known as JAXA, and the Japan agency, which is also known as JAXA, will provide even more detailed data. It has two orbiters, one to study Mercury's surface and exosphere, and another to investigate its magnetic field and interior. With this new wealth of information, scientists hope to finally unlock some of the Mercury's most persistent riddles. From its mysteriously oversized iron core and ongoing shrinking to its surprising magnetic field and hidden polar ice, Mercury truly lives up to its title as the solar system's biggest riddle. It is a small planet that punches far above its weight in terms of scientific intrigue, constantly pushing the boundaries of our planetary theories. Each paradox it presents forces scientists to rethink fundamental assumptions about how planets form, evolve, and operate. The journey to understand Mercury is far from over, and with new missions, the next chapter is unraveling its secrets. It is just the beginning. It reminds us that even the most familiar corners of our own cosmic neighborhood hold incredible mysteries waiting to be solved. So, friends, thank you for joining me on this fascinating exploration of Mercury's enigma. We hope you have gained a new appreciation for this tiny, baffling world. So, until next time, keep looking up and questioning the universe around you. See you in the next one, friends.